Welcome to Thought Frontier.
Right. So today we are diving deep into deep learning.
Deep learning.
We've got a ton of research papers, articles, even a podcast transcript on this one.
Oh, wow.
So it's going to be interesting to see how this goes.
Yeah.
It seems like deep learning is everywhere these days.
It really is, yeah.
It's being used for everything from self-driving cars to
It's amazing.
medical diagnoses.
It is.
It's kind of mind-blowing.
Yeah, it's really taken off in the last, 5 to 10 years, really exploding in popularity. But it's not new is the thing.
Right.
This has been a long time coming.
Oh, really?
Oh, yeah. Deep learning. It's got a really interesting history, actually.
Okay.
Goes way back, like decades, to the mid-20th century.
Wow, the 1950s.
Yeah.
Back when,
Like Elvis was king.
Yeah.
And scientists were, just starting to tinker with the idea of thinking machines, artificial intelligence, all that.
Just what were those early computers even like?
Well, they were nothing like what we have today, that's for sure.
I bet.
But even back then, they made some pretty remarkable breakthroughs.
Oh, like what?
Well, there's this thing called perceptron.
The perceptron.
Yeah, it was basically it was like the great-great-grandfather of modern deep learning systems.
Oh, yeah.
And it caused quite a stir at the time, let me tell you.
So what could it do?
Well, it could recognize patterns.
Okay.
It was like, imagine a computer program that could learn to identify different shapes or tell the difference between a cat and a dog in a picture.
Oh, wow.
Which at the time, that was a really big deal.
It was.
It was like the first time a machine could actually learn in a very rudimentary way.
Yeah, that's huge.
It was huge, yeah.
That is really huge.
It was like this really exciting time for AI research. Everybody thought, we're on the verge of creating true artificial intelligence.
Yeah.
Like the future is now,
Yeah.
But there was a problem.
Oh, what happened?
Well, the perceptron, it had some limitations.
Yeah.
It worked okay for really simple tasks, like distinguishing between a square and a circle, but anything more complex than that, and it just fell apart.
Oh, so it couldn't really handle the nuances of the real world. Okay.
It was like imagine trying to teach a child the alphabet and then expecting them to write a novel.
Right.
It wasn't equipped for that level of complexity.
So what happened? Did people just give up on AI then?
Well, not right away, no.
Okay.
There was this initial wave of excitement.
Yeah.
Like I said, people thought, true AI was right around the corner.
Right.
But then the critiques started coming in.
Oh, no.
Yeah, researchers started publishing papers, pointing out the perceptron's limitations.
Oh.
And then in 1969, this book came out, which is called Perceptrons.
Okay.
And it was like a bomb dropped on the field of AI research.
Wow.
This book, it systematically dismantled the perceptron.
Oh, no.
Showed all of its flaws. And it basically argued that, this whole idea of neural networks, it was a dead end.
Oh, wow.
It'll never amount to anything.
Wow. So from rock star status to a complete blackout.
Exactly.
That's wild.
It was a dark time for AI research. Funding dried up. People stopped working on it.
So how did we go from this AI winter, this dead end, to the deep learning revolution we're seeing today?
That is the million-dollar question, isn't it?
Yeah.
Well, little did those early pioneers know a revolution was brewing in the labs.
Okay.
And it was all thanks to an algorithm that would change everything.
An algorithm that changed everything. All right, you've got to tell me more.
It really did, yeah. This was a game changer.
Oh.
And it all started with something called backpropagation.
Backpropagation. Okay, that doesn't sound very exciting.
I know. It's not the most glamorous name.
Right.
But trust me, it's pretty amazing stuff.
Okay.
So imagine you're trying to teach a dog a new trick.
Right.
Right? Like stay or fetch or something.
Yeah.
And every time the dog gets close to doing what you want, you give them a treat.
Okay.
Right. A little reward.
Yeah.
And over time, the dog, they start to associate the action with the reward.
Right.
And they learn to do the trick.
Okay.
Backpropagation is kind of like that. But instead of treats, we're talking about adjusting the internal connections of a neural network to make it better at a given task.
So the network is learning through trial and error.
Exactly.
Getting feedback along the way. And adjusting its approach Until it gets it right.
Precisely. Yeah, it's like, it's constantly trying to improve to get closer to the desired outcome.
That's wild. So is that when things started to really take off with AI?
It was a big step, yeah.
Okay.
I mean, it didn't happen overnight.
Right.
But backpropagation, it really opened up a lot of possibilities.
Okay.
And one of the earliest and most compelling examples of backpropagation in action was a program called NetTalk.
NetTalk?
NetTalk, yeah. Have you heard of it?
I think so. Wasn't that...
That's a big deal.
Wasn't that a computer program that could, like, talk?
Yeah.
Oh, wow.
NetTalk, it learned to speak.
Wow.
Well, kind of.
Okay.
At first, it sounded like total gibberish.
Yeah.
Like just random sound. But as it was fed more and more data, like text and speech samples, its pronunciation got better and better.
Really?
Oh, yeah. It was amazing.
So it actually learned to, like, speak English?
Well, it was a bit robotic.
Okay.
But it was definitely understandable.
Oh,
it was a major milestone, yeah.
That's incredible.
So for the first time, a machine had learned to speak in a way that was even remotely human-like.
Like watching a baby bird learn to sing, you know?
Yeah, kinda.
They start off all wobbly, but eventually they find their voice.
Exactly. It's fascinating, really.
It is. So we've been talking about, like, deep learning.
Yeah.
And how it kind of mimics how our brains work. But it's not just about algorithms, right?
No, not at all.
There's, like, an actual biological connection here, isn't there?
Oh, absolutely.
Like, with how our brains actually process information.
Yeah, the development of deep learning.
Yeah.
It's gone hand in hand with breakthroughs in neuroscience.
Okay.
Like, for example, you've got the visual cortex.
For visual cortex.
Yeah, that's the part of our brain that processes sight.
Right.
And this is where things get really interesting.
I'm all ears. Tell me more about this visual cortex thing.
Okay, so back in the 1960s, there were these two neuroscientists, Hubble and Weasel, and they made this groundbreaking discovery that won them the Nobel Prize, by the way.
Wow.
They found that the visual cortex, it's structured hierarchically. Yeah, with layers upon layers of neurons. Each layer responsible for recognizing increasingly complex features.
So, like, our brains are basically processing visual information in stages.
Exactly. It's like, imagine a factory assembly line. Right, where each station along the line performs a specific task.
Right.
And together, they all contribute to building a finished product.
Okay, and so what does this have to do with deep learning?
Well, this hierarchical structure, it turns out it's very similar to how deep learning networks process images.
Oh, really?
Yeah, like take convolutional neural networks, or convnets for short.
That's okay.
These networks are designed specifically for image recognition, and they're structured in a way that directly mirrors the hierarchical organization of the visual cortex.
So walk me through this. How does a convet actually see an image?
Okay, so let's say you're looking at a picture of a cat. The first layer of the convenet, it might detect basic edges and lines in the image. The next layer might combine those edges into simple shapes. Like circles and squares. Then deeper layers would start to recognize more complex features. Like ears, whiskers, a tail.
Oh, wow.
And finally, the network would put all those pieces together and say, aha, that's a cat.
Wow. So it's like each layer of the network is figuring out a small piece of the puzzle.
Exactly.
And then they all come together to form the complete picture.
Precisely. Yeah. It's like a really sophisticated game of pattern recognition.
That's incredible.
And this brain-inspired design is a big part of why deep learning has been so successful.
That makes sense.
We've learned a lot from studying the brain.
It seems like it, so...
Yeah, and we're only just scratching the surface.
That's wild. So we've gone from a machine that could barely tell a cat from a dog... to systems that can recognize faces, translate languages.
It's amazing.
Even drive cars.
Yeah.
Like, it's mind-blowing. But there's one thing I'm still kind of wondering about.
Okay, what's that?
Like, motivation? Do these deep learning systems, like, do they want to learn?
That's a great question.
What, like, drives them?
Well, that leads us to another fascinating area of deep learning. Reward learning.
Reward learning. Okay, so we're talking about, like, giving gold stars to AI.
Well, not exactly gold stars, but you're on the right track. It's about motivation, like you said, about giving these systems a reason to learn.
Okay, so how does that work? Like, how do you motivate a computer program?
Well, think about the feeling you get when you solve a tricky puzzle.
Or finally
beat a tough level in a video game.
That little rush of satisfaction.
Exactly.
The dopamine rush.
That's your brain rewarding you with a dose of dopamine.
Right.
It's like, hey, you did good. Have a little treat.
I like treats.
Yeah, who doesn't?
But how does that translate to, machines?
Well, just like our brains are wired to seek out those rewarding dopamine hits.
Okay.
Deep learning systems can be programmed to pursue specific goals.
Okay.
And every time they get closer to achieving that goal,
Yeah.
they receive a virtual reward, which reinforces their learning.
So it's like we're hacking their system.
In a way, yeah.
To make them want to learn.
We're giving them a reason to learn, to improve.
Okay. That's pretty wild. So can you give me an example of this, like in action?
Oh, absolutely. One of the most mind-blowing examples of reward learning is AlphaGo.
AlphaGo. Oh, yeah, I've heard of that. That was the
Go playing AI.
Yeah, the one that beat the world champion.
Exactly. Made headlines a few years ago.
That was huge news. I remember that.
It was a big deal, yeah.
Because, wasn't Go supposed to be this
incredibly complex game?
Yeah, too complex for AI to master.
That was the prevailing thought at the time.
Right.
But AlphaGo proved everyone wrong.
But it did it through, reward learning.
It did, yeah. It played millions of games against itself.
Wow.
Learning from each win and each loss.
So it basically taught itself to be a grandmaster.
In a way, yes.
Just by playing against, its own reflection.
Essentially, yeah. It's a fascinating example of...
That's wild.
Of how far we've come with AI.
So we've gone from, simple pattern recognition to AI that can outmaneuver humans in one of the most complex games ever invented.
And this is just the beginning.
Really?
Oh, yeah. The possibilities with deep learning are pretty much endless.
So where do we go from here? What's next?
Well, for one thing, deep learning has the potential to revolutionize education.
Oh, really? How so?
Imagine a world where every student has a personalized AI tutor that adapts to their unique learning style.
Okay. That would be amazing.
It could identify their strengths and weaknesses.
Right.
Adjust the pace of lessons.
Okay.
Even predict when they're about to get bored and switch things up.
That would be incredible. It's like having a personal coach for your brain.
Exactly, yeah, and that's just one example.
Wow, so it seems like deep learning is going to, change everything.
It already is in many ways.
That's true, but it's also kind of, I don't know, a little bit scary, isn't it?
I can understand that.
What about jobs? Are we all going to be replaced by robots?
That's a common concern, and it's important to think about these things.
Yeah.
But I think it's more helpful to think about it as humans and machines working together, augmenting each other's abilities.
Okay, that's a good point.
Deep learning has the potential to create entirely new industries and job categories.
That we can't even imagine yet.
Exactly.
So it's not necessarily a dystopian future where robots rule the world.
Not at all. It's about using these powerful tools responsibly and ethically.
I like that. Responsibly and ethically.
That's the key, yeah.
Well, this has been an incredible journey.
It has, hasn't it?
We've gone from the birth of the perceptron to the rise of reward learning.
Yeah.
And the mind-blowing potential of AI-powered education.
And we've only just scratched the surface.
That's the thing. It feels like this is just the beginning.
Oh, absolutely. Deep learning is a field that's constantly evolving.
It's exciting and a little bit terrifying all at the same time.
I think that's a good way to put it.
So, to our listeners out there, your deep dive into deep learning may be coming to an end.
But we encourage you to keep learning, keep exploring.
Who knows, maybe you'll be the one to unlock the next big breakthrough.
That's the beauty of it. Anyone can make a difference.
Well, that's all for today's deep dive.
Until next time.
Keep learning, keep questioning, and as always, keep diving deep.